Hello, and welcome back to GradMates. I'm Peter.
I'm Caitlin.
And today we have a fun problem for you. And bet you can't do it. So we're going to do this problem the easy way, the way that everybody should do it. But then I'm going to do it the way that you probably would never think to do it.
Okay, so
you want to start this one?
Yeah.
Okay.
Really what we should do is we have two different functions here with the plus. We should separate it into two different integrals. So I could separate it like this, adding the other one.
Right.
And then I can just integrate both of those with basic trig integration.
As you should.
So the way I do it is I see a 2 out here as I always call it a constant, and that's not the right word for it. What would you call it?
I would call it a constant.
Okay.
It's a scalar or a constant. I mean,
Okay. Maybe scalar's a better word. So I pull it out.
Is that your grad school professors coming back to, like, be formal?
Absolutely. And I see one here as well.
What's a prime number? I'll never forget that.
And then I can just do the actual integration. So the integral of sine is cosine. And by that I mean negative.
Yep.
Plus, and then the integral of cosine is just sine. And then I don't have any bounds here, so I will not forget my plus c.
Perfect.
So that should be the basics, right?
Right. Absolutely. That would be like chapter 4 in my Calc 1 class. Beginning of chapter 4.
All right. Well, I think you were telling me that this was like a problem on your final exam and somebody else had done it a totally different way.
Oh, it was. Yeah. I had somebody attempt to do a U substitution, which we do talk about in Calc 1. And they attempted to do I guess we don't do trig substitutions until Calc 2, but I guess you could still call it a trig substitution. So they tried this weird substitution, got it very wrong. But that just begged the question, could you do it with this substitution? Now, first thing I want to comment on is, I feel like that was a little excessive, splitting it up.
No, it is. No, it is. But I like to have it
And that is why you're
proper.
a good teacher.
Like, I like to show every single step so no one can say I did something wrong.
Am I sensing a little PTSD from some points off?
Yes.
Okay, so this is what my student did. So it was 2 sine x plus 3 cosine x dx. All right, so I had a student say, we're going to do a u substitution, and we're going to say u is equal to sine of x. Yeah, and I thought, okay, that's interesting. I don't know why you would do that, but
I would think about that if that plus was a multiplication.
Oh, yeah. Mm-hmm. If that plus was a multiplication, that definitely would be the substitution you would want to use. Right. I guess even technically, if it was like sine times cosine, you could, there's an identity. 2 sine cosine is sine of 2 times the angle. So you could convert it that way. But anyway, you're right, absolutely. So if you do a u substitution, you've got to get a derivative substitution is what I like to call it, your differential substitution. So you have sine of x, the derivative of that's cosine of x, dx. Oh, can't forget that. My students would give me so much grief if I didn't write it. Now, I know that if I'm trying to get a substitution for dx, because that's what I'm starting with my integral, I'm going to have to divide both sides by cosine. And of course, we're assuming cosine's not 0. Now, when I'm converting to u, I need to have everything in terms of u. So what that's going to tell me is I need to construct a triangle. And this is something, I guess, in 172 that students could do. Because we talk about setting up triangles with expressions like, well, here we have sine of x is u, or u equals sine of x. So the angle is x. Sine is opposite over hypotenuse, so that'd be u over 1. And then by the Pythagorean theorem, this is going to be 1 minus the square root of 1 minus u squared. Like that would be the expression that models that side. And so then, since I need a replacement for cosine in terms of u, I would find my cosine substitution. So cosine of x is just going to be the radical part of that, radical side of that triangle. So now I've got a substitution for cosine. So I'm going to go back into my problem. So 2, and then sine is going to be u, because that was my substitution. And then we have 3 times, well, cosine is that radical. I'm running out of room. I need to shrink this. I write too large. And then this is my integrand, and then I'm multiplying by dx, so that's going to be du over cosine. So this substitution here really becomes du over the radical. So I have du divided by that radical. And then I'm going to distribute that radical. So I'll have 2u divided by the square root of 1 minus u squared. And then I'll have just a plus 3 du. And then I recognize that I'm going to have to do a substitution here on this integral, because if I do u, or we'll change it to w. I think that's the letter that you like to use. So we have 1 minus u squared. So dw. Isn't she like a character from Hey Arnold or something? Or maybe it's Arthur. Arthur?
I think so.
Okay, I don't know. Anyway, so we have negative 2 u du, and I've got the 2. I don't have the negative, so I'm going to write in the negative, and I'm also going to multiply by a negative. Well, actually, maybe I should split this up first. So we'll have the negative, and then the negative 2u over the square root of 1 minus u squared. Oh, my handwriting is getting sloppy. I'm not accustomed to writing kind of, I don't even at an angle like this. And then we have du plus 3 du. Okay, and then this really turns into, if I do the replacement with w, it's going to be 1 over the square root of w dw. Now, I actually personally wouldn't do that substitution. I would just say, oh, I've got my derivatives. My derivative is present inside the integrand, so I can just integrate that radical. And that would be w to the negative 1/2 dw. Now I'm going to go ahead and integrate this thing. So this is just going to be 3u. Then we can put our plus c out here. And then when you integrate this first part, that's going to be a negative. So the new exponent, when you add 1, it's a positive 1/2. Divide by 1/2 is multiplying by 2. And then you have w raised to the 1/2 plus the 3u plus c. Well, w was actually the 1 minus u squared. And then u was actually sine. So we have 1 minus sine squared of x to the 1/2. And then we have plus 3 sine of x plus a constant. And then by the Pythagorean identity, sine squared plus cosine squared is 1. So you could replace 1 with sine squared plus cosine squared, and then the sines would subtract out, and you would just be left with cosine. Or you can just manipulate the identity and say 1 minus sine squared is cosine squared. So you have cosine squared to the 1/2 plus 3 sine of x plus a constant. And then you would square root the something squared, so you would just say cosine of x plus 3 sine x plus a constant.
That is crazy.
And I just thought that was really fascinating that you could do this. Now, I know there's always a little nuance with square rooting something squared because it's really absolute value.
Right.
So if you were dealing with a definite integral, you would just need to consider what quadrant you're in and determine, well, is cosine positive in that quadrant or cosine negative in that quadrant? So, but we're just not going to use the absolute value bars. We're just going to drop it because I think we got the same thing.
Yeah.
Perfect.
Crazy.
I think that's really cool.
It is.
So I can tell you for certain, my student definitely did not do any of this and got it very wrong, which is okay. I mean, I mean, I
They
feel
tried.
like they tried.
Yeah.
It's A for effort. All right. Well, I think that'll do it for this one.
Right. We'll have to do some more integration techniques next time.
Yeah. I'm excited. I'm teaching Calc 2 next semester, so I'll be doing all kinds of integration. And I love me some integration.
All right.
So thanks for watching.
We'll see you next time.